So hello everyone. In this video, we are going to study the electronic configuration and the concept of valency. We have seen the last videos, the atomic structure and Bohr's atomic model, Thomson's atomic model, Rutherford's atomic model, Dalton's atomic model, and the principal fundamentals of atomic structure. In this video, we are going to see the electronic configuration and the valency concept. So let's get started. So first we'll see the distribution of electrons. We know that the electrons were invented first by the Dr. Thomson's, okay? After that, the Rutherford Goldfall experiment has been done, wherein they have put that there is a nucleus inside of an atom and the electrons moves around the nucleus. And the last Bohr's experiment, what we have seen, yes, electrons are there and they are not moving randomly. They have a predefined path, okay? This path is known as orbit, or you can call them as a shell. So yes, this is the structure of atom, wherein you can see the central part is nucleus and this 1 2 3 4 or K L M N, these marked as the number of shells or the number of orbits. Remember that the shell having the closest of the nucleus is termed as 1, okay, and then 2 and 3 and that wise likewise. So yes, now here we'll discuss what is the distribution of electron. Means suppose I have the x number of electrons for this element, how this x number of electrons been distributed in these orbits, okay? So for that, one generalized formula is given here as a 2n square. Okay, so wherein n represents the number of shell, the number of orbit. Okay, for your sake of understanding, I have given here one table. Listen everyone, because of some time constraint, if I explain everything very detailed and in slow way, the video time will be it will be very lengthy, and so to avoid that I am just moving fast. If you don't understand anything, the advantage of being this video lecture, you can go and rewind and watch it again and again, so the concepts will clear for you. Yeah, so let's get started with this table. So yeah, so in this table, the first column I have given as a shell number 1, 2, 3, 4. The 2n square, that is n, we are putting the shell number 1 here. If I put n is equals to 1 here in this formula, 1 raised to 2 is equals to 1 and 2 into 1 is equals to 2. That means the maximum number of electron in the shell number 1 can be only 2. Okay, maximum means it could be 1, it could be 2, but it cannot be 3, 4 and 5. For the shell number second, if I put n is equals to 2 over here, 2 to the power 2 is equals to 4, 4 into 2 is equals to 8. That means that the maximum number of electrons in the shell number second can be only 8. Okay, it means that it could be 6, 7 and 8, but it cannot be 9 and 10. The maximum number the shell number second can hold is only 8. Okay, and like that for the 3 is 18 and for the 4 is 32. I hope you understood. With the examples we'll see here. In the last, we have seen the distribution of electron. We have discussed there the number of electrons. Here we'll discuss the energy of electron. And the concept is very simple. For example, these are the number of shells. And as you can see here, the first shell is having the lowest energy of electrons. Okay, the electrons which present in the first shell have the lowest energy, then that of seconds are having lowest than that of third, and the highest energy of electrons are the electrons present in the highest shell. Okay, first, second, third and fourth, and the energy is also moving lowest, higher than that, and the fourth one is having the highest energy. So these are the distribution of electrons, distribution of energy of electrons. Here, some practical examples I have given in the table, and we'll see what is the electronic configuration. So we'll discuss this table. In the first column, I have given some elements. Examples I have given as helium, carbon, sodium, silicon and argon. The symbol is given as He, Ce, Na, Si and argon Ar. So atomic number, here I have mentioned helium atomic number is 2. If the total number of, okay, what is atomic number? What is atomic number? I hope you remember in the last lecture that we have seen in the fundamental principles of atomic structure, atomic number represents the proton of that element. Okay, that means the proton number is the atomic number. And the thing is that number of protons are always equal to the number of electrons. Okay, number of protons having positive charge, number of electrons having negative charge, they balance each other, and hence the atom is electrically neutral. So yeah, atomic number is 2. It means it has two number of electron. It has total two number of electrons. So what will be the electronic configuration? The first shell can have the maximum number of electrons is equals to 2. So yeah, the electronic configuration of helium is only 2. Now see here, the shells are there like K, L, M, N, and for example 1, 2, 3, 4. When we represent the electronic configuration, it is represented by this. It is separated by the comma. So you can understand the first number is first shell, second number in second shell, and like that. We'll take the next example as a carbon whose atomic number is 6. It means it has total number of electrons is 6. Okay, where in first shell we can have only maximum number of electrons is equals to 2. Now out of 6, 2 has went here. So how many are remaining? 4 are remaining. So that 4 can lie, or that 4 can reside in the second orbit. Okay, is it possible? Yeah. Why? Because second orbit has the maximum capacity of 8. So I can put here 4. So yeah, electronic configuration of carbon is 2 and 4. One more example I'll give you, sodium, whose atomic number is 11. So always remember, the first shell is having the electronic configuration 2. So in the first shell we have given the two number of electrons. So atomic number is 11, means total number of electrons are 11. Out of 11 we have given the two number in the first shell. That means 9 number of electrons has remained. Okay, so can I put 9 number in the second shell? No, second shell has the maximum capacity of holding the electrons is equals to 8. So I have given here the 8 here, and yeah, 2 plus 8 is equals to 10. That is one more is remaining, so that one can be given in the third orbit, right? Okay, so like that, there is for silicon and argon. You can just revise by your own. The valency, what is valency? Valency is the concept. The topic of this video itself was the valency and the electron configuration. So what is valency? Valency is a terminology, or you can say is something related to the outermost shell. Okay, why is outermost shell? We'll get to know why, what is that concept. So for now, just remember the outermost shell is always named as the valence shell. Okay, whichever the thing is outside is called as a valence, right? Valence shell, and the the electrons, okay, present in the valence shells are known as the valence electrons. That electrons are related to valency, that's why everything is named as in the valence shell. Okay, outermost shell is valence shell, and the outermost electrons are known as the valence electrons. So here one example is given as the helium having the two number of electrons. Outermost shell, what is the outermost shell? It has only one shell, and hence it is named as the outermost shell. Is filled. Okay, two electrons are there and the two is filled. It is satisfied. So basically, whenever the shell is filled with the number of electron 2, in this is terminology is known as the electron duplet. Okay, duplet. Now it is 2. It has no any electron vacancy. That's why the valence is 0. Okay, valence is 0. It is satisfied. Same as for neon is having the atomic number 10 and the electronic configuration is 2 8. It means it has already 8 electrons in the second orbit. It has no any vacancy. So valence is 0 here. Valence is 0 in the both the case. When it is duplet and when it is octet, the valence is 0. So when the valency concept term make in the picture, the atoms of element except inert gases have the tendency to combine with the other atom having a non-zero valency. So other than that, some elements are there except inert gases, because inert gases don't take participate in the formation of molecules, okay, and to make a compound. So the atoms are having some elements which has a tendency to combine with the other atom. Why? Because of their valency electrons. Valence electrons, for example, hydrogen atomic number is 1. It need one more to make it stable. Its valence is 1. Sodium 281. It can remove out of this one electron and it will become stable by 28. As is okay. Hydrogen and sodium example. So these two example we'll see in the next video. See here. This whole table is given just to understand you the concept or the relationship between the valency and electronic configuration. Okay, so in the first column what I've given you the serial number, second column symbol of elements I've given here. Here we are discussing about hydrogen, here we are discussing about chlorine, neon, fluoride, fluorine, sodium, magnesium, carbon, and aluminium. So when they combine with other atom, they found a compound. So here I have given the molecular formula of the compound, and this is just for one example I have given you. When hydrogen combine with the chlorine, it makes hydrogen chloride, HCl. So here we are discussing about hydrogen. Atomic number is 1. Electronic configuration is 1. Number of valence electrons, the outermost shell is 1, and the valency of electron will be 1. So here a simple formula is given how to decide the valency of electron. 8 minus x for the x is greater than or equals to 4. Okay, when the valence electrons are greater than 4, we have to do this 8 minus that number, so that will give us the valency of electron. And if the number is less than 4, you can take the as it is. If it is 1, take it as it is. If it is 2, 3 and 4, take as it is. But if it is 5, 6, 7, 8, you have to subtract it from the 8, and that will become the valency of element. So chlorine, Cl. Again, the same molecular compound is HCl. Atomic number of chlorine is 17. So electronic configuration will be 2, 8 and 7. 2 plus 8 is 10. 10 plus 7 is 17. What is the external electrons? What is the outermost shell number? Valence number of electrons is 7. 7, is it greater than 4? Is it greater than 4? Yes, it is. So 8 minus 7 is equals to 1. 1 will be the valency of element. So H is having valency 1. Cl is having the valency 1. So they form HCl. Okay. Ne, neon. They don't combine with the any other element. So there is no compound. But what is the valency? Atomic number is 10. So 10 means 2 and 8 configuration. Outermost electrons are 8. Yeah, so 8 minus 8 is equals to 0. So if the valency is 0, they don't participate in formula of any compound. Next is fluoride, fluorine F, and what is HF? Hydrogen fluoride. So F having the atomic number 9, it means the electronic configuration will be 2 and 7. Outermost electrons are 7 in number. So 8 minus 7 will be 1. So what is the valency of fluorine? Is 1. Having the valency of H is 1, valency of F is 1. And they found compound what? HF, hydrogen fluoride. So same is for NaCl. Let's discuss for the MgCl, magnesium chloride. Okay, why it is Cl2, why it is CH4 and why it's Cl3? You'll get to know after studying this. We'll study for the magnesium whose atomic number is 12. So electronic configuration for the 12 will be 2, 8 and 2. Okay, 2 plus 8 is 10, 10 plus 2 is 12. What is the outermost shell number of electrons is 2. Okay, valency of element will be 2. It not necessarily it should be subtracted from 8. If it is greater than 4, we should have subtracted here, but if it's 2, we have kept as it is. Okay, so the valency of magnesium is 2, valency of chlorine is 1. So that's why this compound is MgCl2. Okay, Cl2 Mg valency is equals to 2. CH4, what is CH4? Is methane. So we are discussing here about carbon. So atomic number is 6. Electronic configuration is 2 and 4. The number of valence electrons is outermost is 4. So 8 minus 4 is 4. Sorry, just taken as a 4. So yeah, that's why the carbon is having the valency is 4, the structure, and the hydrogen is having the valency 1. We have here the compound is a CH4. Here it was 2, it was MgCl2. Here it was 4, it is CH4. Now we are discussing last one about the aluminium. Aluminium having the atomic number 13. Electronic configuration is 2, 8 and 3. So number of valence electrons are 3. So the valency of element is 3. That's why the compound formed is 3. Okay, is AlCl3. So that is all about the relationship between the valency and electronic configuration. I hope you have understood. Thank you.